The operating system controls events within the computer system. It schedules and dispatches processes for execution by the processor, allocates resources to processes, and responds to requests by user processes for basic services. Fundamentally, we can think of the operating system as that entity that manages the use of system resources by processes. This concept is illustrated in the slide. In a multi-programming environment, there are a number of processes that have been created and exist in virtual memory. Each process, during the course of its execution, needs access to certain system resources, including the processor, input-output devices, and main memory. In the figure, process P1 is running. At least part of the process is in main memory, and it has control of two input-output devices. Process P2 is also in main memory, but is blocked waiting for an I/O device allocated to P1. Process P sub n has been swapped out and is therefore suspended. If the operating system is to manage processes and resources, it must have information about the current status of each process and resource. The universal approach to providing this information is straightforward. The operating system constructs and maintains tables of information about each entity that it is managing. A general idea of the scope of this effort is illustrated in the slide, which shows 4 different types of tables maintained by the operating system: memory, input-output, file, and process. Although the details will differ from one operating system to another, fundamentally all operating systems maintain information in these 4 categories. Memory tables are used to keep track of both main or real memory and secondary or virtual memory. Some of main memory is reserved for use by the operating system. The remainder is available for use by processes. Processes are maintained on secondary memory using some sort of virtual memory or simple swapping mechanism. The memory tables must include the following information: the allocation of main memory to processes, the allocation of secondary memory to processes, any protection attributes of blocks of main or virtual memory, such as which processes may access certain shared memory regions, any information needed to manage virtual memory. We examine the information structures for main memory later in the course. Input-output tables are used by the operating system to manage the input-output devices and channels of the computer system. At any given time, an input-output device may be available or assigned to a particular process. If an input-output operation is in progress, the operating system needs to know the status of the input-output operation and the location in main memory being used as the source or destination of the input-output transfer. Input-output management will be examined later in the course. The operating system may also maintain file tables. These tables provide information about the existence of files, their location on secondary memory, their current status, and other attributes. Much, if not all, of this information may be maintained and used by a file management system, in which case the operating system has little or no knowledge of files. In other operating systems, much of the detail of file management is managed by the operating system itself. This topic will be explored toward the end of the semester. Finally, the operating system must maintain process tables to manage processes. The remainder of this part of the lecture is devoted to an examination of the required process tables. Before proceeding to this discussion, two additional points should be made. First, although the previous figure shows 4 distinct sets of tables, it should be made clear that these tables must be linked or cross-referenced in some fashion. Memory, input-output, and files are managed on behalf of processes, so there must be some reference to these resources directly or indirectly in the process tables. The files referred to in the file tables are accessible via an input-output device and will, at some times, be in main or virtual memory. The tables themselves must be accessible to the operating system, and therefore are subject to memory management. Second, how does the operating system know to create the tables in the first place? Clearly, the operating system must have some knowledge of the basic environment, such as how much main memory exists, what are the input-output devices, and what are their identifiers, and so on. This is an issue of configuration. That is, when the operating system is initialized, it must have access to some configuration data that define the basic environment, and these data must be created outside the operating system with human assistance or by some auto-configuration software. Consider what the operating system must know if it is to manage and control a process. First, it must know where the process is located. Second, it must know the attributes of the process that are necessary for its management. For example, its process identification number and process state. Before we can deal with the questions of where a process is located and what are its attributes, we need to address an even more fundamental question. What is the physical manifestation of a process? At a minimum, a process must include a program or a set of programs to be executed. Associated with these programs is a set of data locations for global and local variables and any defined constants. Thus, a process must consist of at least sufficient memory to hold the programs and data of that process. In addition, the execution of a program typically involves a stack that is used to keep track of the procedure calls and the parameter passing between procedures. Finally, each process has associated with it a number of attributes that are used by the operating system for process control. The location of a process image will depend on the memory management scheme being used. In the simplest case, the process image is maintained as a contiguous or continuous block of memory. This block is maintained in secondary memory, usually disk. So that the operating system can manage the process, at least a small portion of its image must be maintained in main memory. To execute the process, the entire process image must be loaded into main memory, or at least virtual memory. Thus, the operating system needs to know the location of each process on disk, and for each such process that is in main memory, the location of that process in main memory. We saw a slightly more complex variation on this scheme with the CTSS operating system in Lecture 2. With CTSS, when a process is swapped out, part of the process image may remain in main memory. Thus, the operating system must keep track of which portions of the image of each process are still in main memory. Modern operating systems presume paging hardware that allows non-contiguous physical memory to support partially resident processes. At any given time, a portion of a process image may be in main memory, with the remainder in secondary memory. Therefore, process tables maintained by the operating system must show the location of each page of each process image. Typically, the collection of attributes is referred to as a process control block. We can refer to this collection of program, data, stack, and attributes as the process image. A sophisticated multi-programming system requires a great deal of information about each process. As was explained, this information can be considered to reside in a process control block. Different systems will organize this information in different ways, and several examples of this will appear at the end of the chapter in the textbook and the next one. For now, let us simply explore the type of information that might be of use to an operating system without considering in any detail how this information is organized. The table that you see here, and continuing into the next slide, lists the typical categories of information required by the operating system for each process. You may be somewhat surprised at the quantity of information required. As you gain a greater appreciation of the responsibilities of the operating system, this list should appear more reasonable. We can group the process control block information into three general categories: process identification, process state information, and process control information.